Okay guys, so the question to you today is, what is common between a solar flare, particles trapped using light, gravitational waves, strongly correlated electrons, and the flight pattern of migratory birds?
The physics of all this is very unclear to me.
Aren't all these topics researched at DPS?
Exactly.
This is where it all started. In 2009, in this building, which was called the J.C. Bose building, in a faculty meeting, we decided that the institute will now be divided into departments. And the Department of Physical Sciences started its journey. In 2015, we started moving to our own campus gradually.
Ah, here you are. IISERs are comparatively new institutions in the Indian educational system. And IISER Kolkata, is the oldest of all IISERs, but we are still only 15 years old. Each IISER is generally known for a certain discipline in science. And in that way, IISER Kolkata is known for physics.
It is true that I did take the very first class in the IISER system. It was more or less an accident. We started classes one day before IISER Pune did, and the very first class happened to be a physics class. I was a visiting faculty at that time. There were very few permanent faculty in the institute when we started. By now, we have of course become a much, much bigger force than we were back at the day.
And now we have 32 members of faculty, about 300 students, of which 170 are doing their majors in physics, about 125 research scholars, and 10 postdocs. And the department, we run with the help of about 9 support staff. Our research covers, pretty much all areas in physics. We also have 2 research centers, the National Center for High Pressure Studies and CESI.
The Center of Excellence in Space Sciences India is a unique multi-institutional initiative involving faculty from the Department of Physical Sciences and researchers from astronomy and space science organizations from around the country. Our research focus is on understanding the activity of the Sun and its impact on our space-based technologies and the possibility of life in planets. We're also involved in multiple missions of national importance, like the Aditya L1 space mission, which is India's first mission to observe the Sun's activity, and the LIGO India mega project, which hunts for gravitational waves from exotic events in the universe.
As a part of LIGO scientific collaboration, we work on gravitational wave data analysis. We mainly work on detecting signal in the LIGO time series and look at the signal from astrophysical black holes.
At CESI, based on observations from satellites and our indigenous computational modeling, we have now started providing forecasts and space weather assessments.
For the first time in India, we have developed a computational module to simulate the space weather, basically the space environment of a planet.
This helps in protecting our space-based assets and in space mission planning.
With our colleagues in the physics department, CESI has initiated a novel Make in India space optics instrumentation facility.
This is something that we really take pride in. Make in DPS is what we say. So our colleagues have actually developed several in-house experimental facilities, either developed completely by themselves or around some commercial setups.
So let me talk about an apparatus that we have assembled in our group that allows us to independently vary the two perpendicular components of magnetic field. We call this a vector magnet setup, and one can think of many interesting experiments that can be done here.
So one of the things which we do in our lab here is to work with very high magnetic fields, and this is a pulse magnet which the students have made completely on their own. The idea is that you have a bank of capacitors and you discharge them through a coil, and ultimately we end up with a magnetic field which is the highest in the country. So we can go to 35 Tesla here. Next door, Bipul Pal, a collaborator, again works on photoluminescence spectroscopy, and we sort of do some measurements there.
We are studying various fundamental interactions of light with matter. For example, in a pump probe measurement, a 100 frame per second laser pulse drives a sample out of equilibrium, and then a delayed probe pulse monitors how the system returns to equilibrium through various scattering interactions in the ultra-fast timescales.
Here is one demonstration of this thermal lensing effect. So you can see that at the far field we are getting a ring kind of pattern when that focused laser excites the sample.
Professor Kamaraju, he is also using femtosecond lasers to study terahertz spectroscopy in various materials.
In this lab, we use femtosecond pulses generated from femtosecond amplifier, and we use these pulses to look at various dynamics of electrons and quasi-particles. We also generate terahertz pulses which are in between microwave and IR, and with these pulses you can directly look at these quasi-particles. The radiation directly resonates with quasi-particle energy, so you can look at them directly.
We actually do a different type of spectroscopy. This is called force spectroscopy using light. We trap microparticles in liquid and air.
You can see this particle has been trapped in air for the last 4 hours using red light from laser.
So not only microparticles, we can even trap microbubbles, as you can see them, using light. These microbubbles are used to pattern plastic electronics to development of biosensor.
We also use light, but polarized light, to probe matter at nanometer length scale. Here we have developed a unique Muller matrix polarization setup to study various light matter interaction at micro and nanostructures.
Instead of micro and nanostructures, we use micro and nano optical systems to study the classical optical analog of quantum weak measurement for our fundamental interests and potential applications.
Not only in research, we have used light to set up very advanced level teaching experiments which are not done nowhere in India in the MS level. There are other interesting works going on in the department. For example, Professor Satyabrata Raj, whose basic training is in condensed matter experiment, works on theoretical aspects of nanoplasmonics. Professor Gautam Dev Mukherjee uses optical spectroscopy, optical Raman spectroscopy for various applications.
So the Raman spectrometer is also a part of the National Center for High Pressure Studies, where we investigate materials at the extreme conditions of pressure and temperature. The temperature ranging from 6 Kelvin to 3000 Kelvin, and the pressure ranges from ambient to almost at the outer core of the earth.
Professor Dhananjay Nandi works on molecular dynamics, so he has developed a very unique velocity imaging spectrometer in-house. Professor Rangit Bhattacharya studies quantum dynamics of open systems.
So we look at the dynamics of quantum systems which are connected to environment, and as a result they suffer from damping, like damped harmonic oscillators. We use these systems for making quantum storage, for making quantum sensors, and of course in quantum computation.
Welcome to Quantum Condensed Matter and Quantum Information Processing Lab. Here we measure exotic properties of electrons at low temperature in the presence of magnetic field, and also in the presence of high frequencies. So that leads us naturally to the setup that we are studying here. We have a home-built electron spin resonance setup, and we have also built a pulsed electron spin resonance setup. All the intricate microwave components which are part of this setup are here, which was primarily brought together by the students, and this setup cost us less than 1 crore, and a commercial pulse TSR setup would be about 7 crores.
So physics is this unique subject which has two different categories of researchers, experimentalists and theorists. So you just saw the great facilities that we have developed in terms of experiments, but we also have some really motivated and passionate theoreticians.
Our conference on quantum information quantum technology every summer has been very successful. Our group has been involved in the area of quantum computation and quantum information science, as well as science dealing with ultra cold atoms. And in the domain of quantum computation, we are primarily concentrating on theoretical aspects. We do work on IBM quantum computer platforms sitting from here.
Consider the amazing technological progress made in smart mobile phones, laptops, the internet, fuel efficient cars, climate efficient homes, even the camera with which you're shooting this video. Condensed matter physics is certainly the most diverse field of physics. It gives me great satisfaction to be able to say that the research groups of the 5 condensed matter theorists here at the Department of Physical Sciences, IISER Kolkata, pursue an equally diverse range of research interests. I'd like to give you some examples. Amit Ghoshal's research involves understanding the inhomogeneous phases of strongly correlated quantum matter. Shubhashish Sinha, on the other hand, studies the emergent quantum chaotic dynamics of interacting many body systems, as well as the non-equilibrium dynamics of ultra-cold quantum gases. Bhimalingam Chittari's research is focused on developing the quantum theory of functional materials. He is presently working on the formation of two-dimensional Moire superlattices and their applications. Soren Das's research involves studying quantum transport in various low-dimensional quantum systems with a special focus on those involving topological states of matter. I am Siddharth Lal, and my research involves understanding the properties of novel states of quantum matter. This includes studying strongly correlated electron systems, frustrated quantum magnets, and phases with topological order.
My name is Supratim Sengupta, and I'm here to represent 6 other colleagues from DPS, and we work on a wide variety of areas that span across a diverse set of topics that transcend disciplinary boundaries. Dr. Soumitra Banerjee works on the nonlinear dynamics of quantum and classical systems. Dr. P.K. Mohanty works on self-organized criticality, non-equilibrium statistical mechanics, and models of active matter. Dr. Ananda Mohan Ghosh works on biophysical models of gene regulation, models of random matrix theory, and neurophysics. Dr. Arindam Kundugrami works on polymer physics. I work on origin of life, evolution of cooperation, and more generally models of decision making. And finally, Dr. Rumi De works on cellular biophysics, pattern formation by bacterial colonies, and flocking dynamics.
We study dynamics of living system. We develop theoretical and computational model and explore the underlying dynamics of such collective system, different cellular processes, flocking, prey-predator dynamics, using the tools from physics. We also look at how wounds heal, how cells crawl, they talk to each other, how they sense the forces in the surroundings, and it strongly affects the tissue development, embryo formation, and also cancer metastasis.
The research interests of our theoreticians are really diverse, ranging from predator-prey interactions to particle physics.
This group represents a rather large area of research, including the smallest as well as the largest distance scales in this universe.
So for example, some of the problems that the group discusses about dark matter
and dark energy and neutron star and or the astrophysical systems. And
we also study some particle physics and like Higgs boson and its interaction with other particles that we have in nature. We use techniques like machine learning and other data analysis, detector simulations to study such things.
We have some common papers as well of common interest. Many of us are writing papers with each other.
I joined DPS very recently. My primary research interest is computational astrophysics, and I mostly work on studying the dynamics and radiative transfer of astrophysical plasma around compact objects such as black holes, neutron stars, etc.
Our department colleagues and students are in the need of heavy computational. So we provide high performance computing facility. Department Computer Committee will take care of the maintenance and its facility.
So just like the computer committee, we have several committees actually which help the department run smoothly. So these committees give us proposals, and these proposals are discussed in detail in DPS meetings, which are very spirited and animated. Everybody has opinions. But then we typically take decisions by consensus, and afterwards we invariably go out for coffee.
Okay, so remarkably we seem to have covered everything in the agenda. Okay. That's fantastic, yeah? Great.
Okay, so we're done?
Yeah.
So let's break for coffee then.
All right, sure.
The teaching is good at DPS. As I am a BSMS student, teacher দেখতে গিয়ে শিখে ভালো লেগেছে।
Our teaching vision is that one cannot do research well unless one is involved also in dissemination of knowledge, that's teaching. So our faculty are involved in both teaching as well as research. Similarly, for the students, we believe that only theoretical knowledge doesn't suffice. One has to also be exposed to experiments, and only being exposed to experiments also does not suffice. One has to be strong in theory. So we have theory as well as experimental subjects going side by side.
So these are some of the postulates of quantum mechanics. But what exactly are postulates?
Getting physics is tough. I mean, only the very best get to select the physics, and over the years it's only the top students who are getting inducted in the discipline. So these students who are interested in taking physics, they are selected from our 5-year dual degree BSMS program. We admit students in this program from KVPY, JEE Advanced, and from state and central boards through our own IISER aptitude test. In their 3rd year, they select one subject out of the 3 pre-major to be continued as their major subject.
So DPS admits PhD students primarily through 2 channels. Firstly, the students who have their own fellowships such as UGC, CSIR, JRF or Inspired. In addition, DPS offers a few institute fellowships who work on specific research project. But even then, these students must also clear at least one national level eligibility test such as JEST, JAM or CSIR NET.
Integrated PhD program. We select students who qualify in JEST or JAM, and they are finally selected through an interview process, and they have rigorous coursework for first 2 years.
After 2 years of their master's program, follow the same PhD program as a regular PhD student.
The students are doing really well. The major students are getting placed in Ivy League universities. Princeton, Stanford, Caltech, you name what. And even in India, we're getting good places such as IISc and TIFR.
When I was a student at IISER Kolkata, Department of Physical Sciences, I had taken a wide range of courses such as electromagnetism or quantum mechanics or fluid magnetohydrodynamics, as well as focused courses in programming languages such as Python, C, and Fortran. Currently, as a PhD scholar at Princeton, my research involves significant amount of both theory and computation. And I think that the curriculum offered by DPS had prepared me adequately well to take up all the challenges as a PhD scholar.
Besides doing research, we also organize student-coordinated seminars, conferences from active chapters like SPI, Optica, and also some student talks from GLUON, the departmental journal club.
Not only the student activities, the department also has a very vibrant seminar program which consists of one monthly colloquium which we host on first Wednesday of every month. Additionally, we also have 3 departmental seminars which we host on other 3 Wednesdays, and we host also one yearly Bibha Chaudhary Memorial Lecture.
हम लोग लैब में तो रिसर्च करते ही है, साथ ही साथ आउटरीच भी बहुत सारे करते हैं। कई बार हर 2-3 महीने में आसपास के स्कूल कॉलेज के स्टूडेंटों को बुलाकर यहाँ पर छोटे छोटे एक्सपेरिमेंट को डिमॉन्स्ट्रेट करते हैं, साथ ही साइंस के बारे में उसे जागरूक करते हैं।
The aim is to motivate school children for pursuing science as a career, and to motivate general public, we conduct workshops for school children from different parts of the country. We conduct teachers training programs and arrange popular science talks.
So our outreach program is like helping curious minds to make headway into comprehending something unknown. So you must not take away this pleasure from yourself, this joy of doing physics or the joy of doing science in general.
So that's really it, you know. We publish our research in these big scientific journals like Science and Nature Communications and PRL and Nano Letters and all that. But what really drives us is this joy of physics, this happiness that physics provides. Because finally in life, what really matters is being happy, right?
Take out.
We hope that this little glimpse of our research will entice you to know more about the work we do. Thank you.